Hello everyone, welcome to the Mixed Bag series that I started a while ago, hoping to cover various different topics from the networking world. This way I can be of help to an audience looking for guidance on specific topics, or for anyone and everyone who loves to learn new things just like me. Previously, I had given a presentation and some tips on how to get started on TCP dump. I got an overwhelming response, and thanks to everyone on that. Now, let's get moving to the first video, which is about EAP. EAP stands for Extensible Authentication Protocol. Many of us don't know where to start from when trying to understand EAP. There is so much out there on the internet for this topic to confuse a beginner. This video is focused on giving you, yes, you who is watching the video, to understand and absorb the basic concepts of EAP. I can't stop emphasizing the need for foundation level knowledge. All concepts should be learned from ground zero, including this one. This question might pop up in your mind. Is this a protocol or a framework? The answer is no, it is not a protocol. It is rather a framework. A very basic reason for this is EAP as a framework never flows through a wire or over the air. Some might have doubts regarding this. I will later tell you exactly what goes on the wire and over the air. However, this framework helps structure many protocols which can be used, which we will discuss later. What is EAP? It provides a very basic request-response protocol framework over which we can implement a specific authentication algorithm, a so-called EAP method. Commonly used EAP methods are EAP MD5, EAP-TLS, EAP-TLS, and EAP PEAP. In simpler words, you can ask for something and then you can get something in return. In all this transmit and receive, an authentication algorithm is used to protect the data within. So who does all of this transmit and receive? There are three components in this conversation. The supplicant. This could be a software installed or built-in running on your Windows machine, or a built-in software on your smartphone. In simpler words, someone who wants access to the network and approaches the gate for network access is a supplicant. What is this gate? This is the authenticator, the second component. The authenticator is usually a device which provides a path to the network or the network resources. This gate or device can be instructed to either allow or deny access to a supplicant. Who gives this instruction? The authentication server makes this decision, which is the third component. The standard that was built to govern the way EAP authentication methods are used was called 802.1x. EAP was originally used in PPP when it was brought into use. Later, when 802.1x was developed, usage of the EAP framework was extended to wired and wireless communications. The EAP layer's representation will give you an idea where EAP is used and how the authentication protocols are incorporated into this process. The PPP, Ethernet, wireless LAN, and token ring networks are all capable of using EAP. This can be used to grant network access to the end user. EAPOL is the encapsulation technique used for the authenticator and the supplicant to communicate over the LAN, including Ethernet and WLANs. The type of EAPOL frames are the following. EAPOL start. This frame is always sent by the client or supplicant to notify the authenticator that it requires access to the network. However, this frame is not mandatory. The authenticator hardware should be able to detect the supplicant's presence and propose an EAP identity request. This identity request frame is meant to collect identity information from the supplicant. The supplicant responds with an EAP identity response with the identity information present within. These type of frames are categorized as EAPOL packet type frames. Another type of frame is the EAPOL key frame, which is used in the wireless 4-way handshake and to share GTK updates. EAPOL logoff is a frame used by the client to indicate that it wants to end the network access connection it established before. The EAP MD5 challenge method, which is described in RFC 2284, enables a radio server to authenticate a connection request by verifying an MD5 hash of the user's password. The server sends the client a random challenge value, and the client proves its identity by hashing the challenge and its password with MD5. The diagram displays the flow of different packets between the three components. This method is vulnerable to replay attacks and is avoided in today's networks. PEAP, on the other hand, provides an encrypted and authenticated tunnel based on TLS. Therefore, the EAP messages encapsulated inside the TLS tunnel are protected against various attacks. PEAP comprises of two phases. In the first phase, a TLS tunnel is negotiated and established. The client authenticates the server by using a certificate. Optionally, the server can also authenticate the client. In the second phase, EAP messages are encrypted by using the key negotiated in phase 1. MSCHAP v2 is quite often used in the second phase at many customer environments. The diagram displayed over here explains the PEAP process with MSCHAP v2 as the second phase. I plan to make a more detailed video on this topic. Stay tuned for that. But for now, here is what the process looks like. EAP-TLS is widely used as it involves digital certificates and is the best option if you're focused on security in your network, but this deployment is complex. The EAP-TLS is based on transport layer security to provide a protected cipher suite negotiation, mutual authentication, and key management. Having both server and client-side TLS ensures a higher level of security. Although a Cisco proprietary method, EAP Fast is worth a mention as it gets the job done. This deployment is complex and takes a bit of planning, but it fits nicely if you have a Cisco shop. Thank you for watching this video on EAP and its basics. Stay tuned and subscribe for more technical training videos. Feel free to use the comments section for any feedback or topic requests. I would love to hear from you guys and let me know if you want me to elaborate on any concept that you feel is difficult to grasp. Happy learning!